Hi there, this is Dr. Everybody with Project 8. This one takes a little time, but it will look familiar to you. We got a CSV file, we're gonna read the data in, and then once we have that data read in into a dictionary this time, then we're gonna look at that data and say, okay, let's look at the data by year. Let's look at the data by cities. Let's look at the data by months. So we're going to just sort of slice and dice the data, but the basic idea is read a data file, do something with it. And this is an exercise in dictionaries, so we're going to be building dictionaries. And the key of the dictionary is going to be states, like Michigan, and then the values will be a list of lists. Each city and day will have values of pollution, nitrous oxide, ozone, things like that. And then we're going to have a list of those lists. So like for Michigan, it'll have Detroit on January 1st and Detroit on January 2nd. All through the year, and then it will have Grand Rapids on January 1st, and each one of those cities and dates will be a list, and then we'll have a big list of all the cities and dates in the state of Michigan, and then the same thing for another state like Maine, for example. You have Portsmouth and Presque Isle and some of these other ones. But that's the basic idea. So let's take a look at it. First of all, I did make a change in the project description just to make it a little easier to read. For any particular state, which I've mentioned, and city, we have and date. Then we have 4 pollutants that we're dealing with here. And they each have 5 values. And these are the 5 values. When we had this document originally, we didn't have the values in the same order that they appear in the data file, so I fixed that. We were getting some questions about that, and why not make them in the same order? So I made that change to the document description. We actually don't give you the whole data file. The whole data file has 4 million lines in it, and it takes too long to run the tests on Mirror with that. So we create some data files by just grabbing 2 or 3 states, and then that makes up the data file, which I called small. And then for the blind test, well, guess what? I just grabbed a couple of different states. It was pretty easy on that point. So we have an open file, and then we read the file, and as I mentioned, for a state we'll have a list of lists, not just 3, but thousands, and each one of those will have a city, a date that the pollution was collected on, nitrous oxide, ozone, sulfur dioxide, and carbon monoxide. The mean values for each of those. That is this value. Okay, but we have to be careful because there's junk in here that we don't want. So we say we're going to ignore 2 types of records. If the AQI value is blank, we just toss out the record. It's just not complete data, is basically. And then we ignore duplicate records. That is, records that have the same city and date. And what we do is we keep the first record in the file, and we discard any subsequent ones. And we'll assume that they're on adjacent lines because they are. And in the notes, we tell you how to do that the right way. If you don't do it the right way, the program will run too long and your test will just time out on Mirror. These mean values that we collect, we convert them all to floats, and you don't round anything in there. But here's the catch. They should be in parts per billion and some of them are in parts per million, so you've got to find those and multiply by 1,000. How do you know if it's parts per million or parts per billion? Units. Okay, that tells you what units. It will tell you it's in parts per billion or parts per million. So we have to clean up this data file. In fact, the read file function, I think, has you know, it's not like rocket science hard, but it's messy. You know, because we have two types of records to ignore. We have to select particular ones, and we have to watch out for this issue of billions and millions. Now, once we have created this dictionary, all right, and it's a dictionary with the keys by state, then we go ahead and we do some other things like totals up over years. Well, we have 16 years of data, and there are 4 chemicals. And so for each year, we find the sum of the 4 chemicals. So that would be so this first one is the nitric oxide. The second one is the ozone. Third one is the sulfur dioxide. Fourth one is for the carbon monoxide for the first year. And then we do the same thing for the second year, and so on. So we always return a list of lists, and then out of all these values, we want to find the one maximum and the one minimum value. That's like to say, okay, so what of all these pollutants, which one has the highest value? Of all these pollutants, which one has the smallest value? And then we go through, taking the same data that we have, we will then organize it by city, and then again our 4 chemicals. And then finally we look at the most pollutants per month, and we're going to put out the top 5. And then there's 4 sorted lists of 5. Right? There's a list for, again, our 4 chemicals and the top 5 months. And as we did in the previous project, there'll be values that are useful there. Then we have a function which displays things, and then another one that does a plot. A couple of things are important under the notes. One is that we want to use the CSV Reader. The reason we use the CSV Reader is that some of the columns are messy, and the CSV Reader will take care of that. And in fact, it will have already done the split for us. So it gives us lists. And so we import at the top of the file, then we create this thing called a reader. And I even show you how to grab the header. And then once you have the reader, then it's just for, in this case I say line list, just to emphasize the fact that we're going through it line by line, and it's already a list. I mentioned about checking for, when we read the file, checking for duplicate cities. And I describe a process of doing that. That's the way you want to do it. All right, so that's quite a bit of stuff. Let's take a look at some code. So here's I printed out the file. It would be a lot clearer if you opened this in Excel. But one of the things that you can see with this is that there's a lot of header information here. All right, you know, ID, state code, county code, site number, address, state. Okay, so there's one of the ones we're interested in. State, city, we're interested in that. There's the units, there's the mean, and so on. And then there's the AQI that tells me whether my data is any good. So we're interested in particular columns there. And the first file I give you is a tiny file. It has something like 20 pieces of data in it or something like that. So what I do is we have a there's an open file function. And we just get to use the file that we've had before. But to make my life easier while I'm testing, I just fix it. Then the interesting one is that we have to read the file using our file pointer that we send it. We're going to use the CSV, and that means that I create a reader. Using the file pointer. And we can skip the header. And then I can go through the file. So we go and we call the open file, gives us a file pointer. We send that file pointer to the read file. We do something, and we return a data dictionary. This is the simple one. You guys all have the complex one. I do this just to give me some, so I don't have to keep typing that in while I'm testing. And then we have our 3 steps. We have the reader, we get the header, and then we read through the file. Let's see what that looks like. And so what this does is I've skipped the header, and we see we've got a bunch of lists of the data that I might be interested in. And let's take a look with the, here we go. One thing I did to play around with these pieces of data is to actually look at the information in the header that we might be interested in. And I also added a separator just so that I can see this information a little better. And so now I can see, what do I have here? I have I can see that there's my state, there's my city, there's a date called date local, and then I had a list of all my nitrous oxides, the units, the mean, and so on across there. And this is a way to check that I have the right indices. Okay. Now that's only for one of the chemicals. You got to do also collect the other chemicals, but that's one way I had of checking. And so now I can hide that information, go back to printing everything, and now I can print out something like my city, my state, and let's print the units, and let's print the AQI. And so we see here I got Michigan, Detroit, parts per billion, and parts per million. So I went too far. I actually wanted to get the AQI value, so let's fix that. There we go, that's better. So I have Michigan, I have Detroit, I have parts per billion, and then I have the AQI value. And you know, why do I care about that? Well, in our specifications, we say if the AQI value is empty, then we skip it. Now this actually won't skip any in here, but that's you know, and I have to do that for all the AQI values. Now all these you can see are in parts per billion. Unfortunately, we should have had a case like that. So what I did is I just, in the CSV file, which is pretty easy to do, I created another one that had a parts per million in it, just so that I could check. And so I want to say if is in my the data type that I have here, which is my 9th item, and it'll just, I can just check to see that I in fact catch that. And if you look on here, you can see that, yep, there's the line that I want to catch. So there it is. I'm checking for that. And what do I have to do? I have to take my data and multiply that by 1,000. So here it is. I skip some stuff here. And then I adjust values when they're parts per million here. And then I'm cleaning up my data to collect up and put into a dictionary. And in your labs, you've been building dictionaries, so you can copy that that code to make a dictionary in right here. So it's like, you know, what do? We will build a list, and then we will put that list in a dictionary using code from lab. All right, and so that then builds our dictionary, and then in here I have to return that dictionary. All right, and so now I have a way of doing that. You know, we've got that code from the lab. We can build the dictionary, and you can test that out. The one other thing I want to show you is I talked about how we built stuff by years. So let me grab some information from there. So I'm just copying and pasting from the file description, and let's take a look at the file, the function dstate. And what do we want to do in here? Well, let's actually take a look at the dictionary that we have. So for keys and values in my items, print keys and values. And so what I've done here is I've defined a dictionary just for testing, and then I'm going to try it out. And so let me actually comment these out so that we don't we're not looking at that information anymore. And here's my dictionary. It's got information from Detroit, and it's got information from Maine. Remember, this is a small dictionary just for testing. So then what do I want to do here? Well, if my key is equal to my state, let's just print that. And sure enough, now Whereas before I had Maine and Michigan, now I just have Michigan. Now that doesn't look very nice, so let's fix that out. And let's take a look at the individual lists, just so it displays a little better. So now I've extracted these out, and let's take a look. What you see is that for a particular city on a date, here's my nitrous oxide value, and what I want to do is I want to add all the nitrous oxides, and I want to add all the sulfur dioxides, and I want to add all the ozones, and I want to add all the carbon monoxides, right? That's what I'm collecting up for the total year. So once you've got it, so we're looking at the individual cities and we have this cleaned up data. Now I just want to say, okay, for this year, and notice, so I'll go, so okay, for the year 2000, add the date up for everybody in Michigan. And then for the year 2001, add its date up. And I will have all 16 of those pieces of data that I then return in a list. So I'll have for the year 2000, I'll have the sum of, I'll have a list that's the sum of these guys, the sum of those guys, the sum of those guys, and the sum of those guys, and then I have 16 of those lists. And then for the cities function, we'll collect it up and do it by cities. And for the months one, we'll do some stuff by months. But we just keep taking this information, slice it and dice it in different ways. It's going to take quite a while to get all this stuff straightened out. There's a lot of work to do in this project. I sure hope you're getting started on it early. All right. Hopefully that gives you enough to get started with. Good luck.